In this lesson, we will look at questions from Unit 6, Section 6.2, Slopes of Parallel and Perpendicular Lines. Question 1. Determine the slope of the line that is parallel to this line segment. So the question is asking us to find the slope of the line and determine what it would be if we have a line segment that is parallel to this line. So let's go ahead now and actually use rise over run to find our slope. So since we have our 2 points here, K and X, we can actually create our triangle from those points. So let's do that first. If you wanted to make a smaller triangle, of course, you can pick any other 2 points on the graph and then do your rise and your run. So we're just going to find our slope. So we have a rise of 1, 2, 3. And we have a run of 1, 2, 3, 4, 5, 6, 7. So we have 7 units for the run. And we're just going to check our line now to see if we have a positive slope or a negative slope. And the line is increasing from the left and is going up. Therefore, we have a positive slope. So now we have to discuss parallel slope. Parallel means we have the same slope for each of the lines. So therefore, the slope of the line that would be parallel to this line segment would have a slope of 3/7. Question 2. EFGH is a parallelogram. Is it a rectangle? Justify your answer. So when we think of a rectangle, we have to look at some of the characteristics of this geometric shape. We know that the length of the rectangle would be equal on either side and the widths are the same. However, we need to classify the rectangle according to its slope and the properties that go with it. So what we need to look for is that opposite sides of the rectangle are parallel. And if they are, we can then conclude that this EFGH is certainly a rectangle. So we're going to have to do a little bit of work for this question. So what our first step would be is to actually go and label the coordinate points for each vertice. So we're looking at E first. E we're looking at is -1 and 3. So I'm just going to write down all the points before we get started. So we have -1 and +3. F is going to be -1, -2, -3, and -2. G is going to be 0 and -3. And H is going to be 2 and 2. So what we're going to do now, we're just going to put a little box around these coordinate points. We're going to use that we want to find our slope. So what we're going to do first, we're going to find the slope of E to F. Because we have to compare our sides EF and GH. So we're going to use our slope formula, y2 subtract y1 divided by x2 subtract x1. So E and F are going to use these two coordinate points. So we're going to have 2 subtract 3 and -3 subtract and -1. This is going to produce an answer of -5 divided by -2. And when we simplify that, that's going to give us an answer of 5/2. So we're just going to have to double check here, and we're going to look for the slope of GH using the same process. So G to H, 2 subtract -3 and 2 subtract 0. So that will give us 5 divided by 2. As you can see here, both the slopes are the same answer, so we can conclude the slope of EF equals the slope of GH. Since they are the same, therefore they are parallel. and that's exactly what we're looking for. So the opposite sides are parallel. Now if we take it a step forward and you want to check E and H and F and G and do the same process as we just did, you would notice that both of those sides would also be parallel. Therefore, you can make a concluding statement that EFGH is a parallelogram, but it is also a rectangle where opposite sides are parallel.